this lesson is focusing on the cosine rule. So let's say I know this angle. Let's call it angle A. Therefore, this side is going to be called side A, side B, and side C. So let's say I know B and C and angle A, and we're going to solve for A. So let's first draw a line creating two right-angled triangles, just like we did when we found our sine rule. Now we can start to use trigonometric functions and Pythagoras' theorem. So we're going to look at this right angle triangle first. So let's label this side D. So if we look at what we have from this angle A, we have an adjacent D and a hypotenuse B. So we're going to have to use our cosine ratio, cosine angle A, which is equal to the adjacent, which is D, over hypotenuse B. But we want to write this in terms of D, as we already know B and angle A. So D is equal to B multiplied by cosine angle A. Now let's have a look at this right angle triangle. So let's call this side E. So E is this whole C side minus D. So let's write that out. So E is going to be equal to C minus D. So this was to find D, and now we're going to find E. So we already know the term D. So we can rewrite this as E equals C minus B cosine angle A. Okay, so looking at our original triangle, let's call this side F. So F is opposite to angle A. So we already have B and we already know C. So what relationship gives us F over B? So opposite over hypotenuse. And that's going to be our sine ratio. So sine angle A is equal to our opposite F over our hypotenuse B. And this can get written in terms of F. So F is equal to B multiplied by sine angle A. So we're going to use all these three terms to find our side A. So we know F and we know E, and now we want to know A. So now we have two sides of a right angled triangle. So we have F and we have E. So we can use Pythagoras' theorem to find side A. So remember, Pythagoras' theorem is C squared equals A squared plus B squared, where C is the hypotenuse and A and B are the other two sides. So if we are looking at this triangle here, and we're writing it in terms of Pythagoras' theorem, our hypotenuse is A. So we're going to write A squared is equal to F squared plus E squared. But we already know F and we already know E. So we're going to go ahead and substitute those in. So now we're going to expand our brackets. So we get b squared sine squared angle A plus, and we're going to rewrite these out in two of our brackets. Okay, so now we can use our FOIL method to expand these brackets. So c times c is c squared, c times negative b cos angle A is minus bc cosine angle A minus bc cosine angle A, and then our last two terms makes a plus b squared cos squared angle A. Okay, so now let's simplify. So our first term can stay the same. These two terms can subtract, so we'll have 2bc cosine angle A plus b squared cosine squared angle A. So what I'm going to do now is I'm going to group these two terms. So b squared sine squared angle A plus b squared cosine squared angle A plus c squared minus 2bc cosine angle A. So if I take out the common term here, b squared comes out the front, and I'm left with sine squared angle A plus cosine squared angle A in brackets plus the rest of my terms. So in here, in our brackets, sine squared plus cosine squared of any angle is always 1. And this is a Pythagorean identity. So this becomes b squared times 1, which is just b squared, plus c squared minus 2bc cosine angle A. And this is going to be our rule. So when can I use this rule? So you can use it on two occasions. The first one is if you have 3 sides. So you know 3 sides, A, B, and C, and you want to find an angle. The second time you can use this is if you have 2 sides already. So 2 sides are known. And the included angle. So how about we take a look at a quick example. So example 1 says to find the length of BC. So we have 2 known sides and the included angle. So let's write out our formula first. So a squared is equal to b squared plus c squared minus 2bc cosine A. So 7 squared, as this is angle B and it looks out onto side B, plus 3 squared minus 2 times 7 times 3 times cosine 35. This simplifies to 49 plus 9 minus 42 cosine 35, which is equal to 23.596. But we want to find what A is, so we take the square root of both sides, and A is equal to 4.596. 1.86. So let's now look at an example where we want to find the angle. So example 2 says find the size of angle R, and that's this angle in here. So to start with, we're going to use the same formula, and we're going to put in all our numbers and rearrange it to find R, but afterwards I'm going to give you the rearranged formula. So let's start with our formula, but I'm going to write it in terms of R, Q, and P. So R squared is equal to Q squared plus P squared minus 2QP cosine R. So let's sub in what we know. So R is 4 squared is equal to Q, which is 6.9 squared, plus P, which is 4.2 squared, minus 2 times 6.9 times 4.2 times cosine of R. So we're going to do a little bit of algebra and rearrange because we want to isolate R. We want R to be the subject. So I'm going to move over a couple of terms. So 4 squared, this is a plus 6.9 squared plus 4.2 squared. So I'm going to subtract them from both sides. Okay, so I've just moved over those two terms, and on my left hand side I get negative 49.25 is equal to negative 57.96 cosine R. So I'm just going to multiply both sides by -1 to make those both positive. And now I'm going to divide both sides by 57.96. So on our right hand side, we're left with cosine R. So my last step is I'm going to get rid of our cosine by doing the inverse. So we're going to have R is equal to the inverse of cosine. So you can just write it to the -1, brackets 49.25 divided by 57.96. Therefore, R is going to equal 31.82 degrees. So if you're not very strong at algebra at the moment, I have written out the formulas for you. So we either have in terms of finding side A, side B, or side C, or angle A, angle B, and angle C. Thank you for watching.